Friends, we got used to be surrounded by voice assistants, and sometimes we talk to them as if they are living people, and sometimes we talk to them feeling that it is a very interesting conversation than with a human being. How do they look like today, what they will turn into tomorrow, how they are created? We're going to speak about it with V.Rakitin, Head of Development Team in Smart Apps Sber Devices, and Ivan Smirnov, Head of Smart Market and NLP Platform Sber Devices. Good afternoon. My name is Ivan Smirnov. I work in Sber Devices. Today I'm going to speak about how artificial intelligence technologies allowed us to create Salute virtual assistant, and I will tell you how you can learn how to create your first apps for the assistants. We have a family of virtual assistants, Sber, Joy, Afina. They are different. They have different voices, style of communication. We have a lot of clients in Sber. That's why we want clients to select the most convenient character. So you see the QR codes in our presentation. If you want to, you can scan them and go to the links and get more details on all this. Our assistants live in mobile apps. First of all, Sberbank Online. Probably you also use the app. More than 65 million is the monthly audience of the app, and the assistant in the lower menu and helps you to work with the bank services. Like you can quickly make a money transfer, so you can just say send money to my mom, and the assistant will help you to do this. We have Sber Salute, a new app where we show ecosystem services of Sber, for instance, Samokat and Smatryoshka and Oko, Sber Mega Market, and many others. Also, we have a range of smart devices the assistant lives in. Popular device is Sber Box, which can be connected to a TV set. And even if you have a very old TV set, it becomes a very smart device, and you'll be able to watch movies or videos on YouTube or play games. And the next device, Sber Portal and Sber Top, and those are devices with cameras, wide lens cameras, and you can make video calls through such devices, call to your relatives and friends, and the camera has autofocus feature. It is very convenient. It tracks your movement. We have smart light bulbs and sockets. It creates a smart home for you through our Salute system. So we are offering multimodal interaction to our users, interaction with our systems. What does it mean? If for a client it is more convenient to make a voice comment to the assistant, we will understand him. If it is more convenient for him or her to press a button on a remote control or on a device or make a gesture, we will also recognize this and will fulfill and will make what he wants. In various life situations, sometimes various means of interactions are more convenient than the others. And now I'll tell you how we are training through algorithms of artificial intelligence, how we can recognize a modality from our client. First of all, I'm speaking about recognition of voice, ISR technology. And this technology is used across all our devices. And there are 11 metrics we are using on our team. Word error rate metric, the number of errors in words, and actually the indicator is very high for various devices. In average, around 2–3% of errors of error recognition. At some points of time, we are working in voice recognition better than human beings. So, if a client asks an assistant something through voice, logical enough that the assistant replies through voice. And another technology, AI technology, is used here, generation of voice model. And the task is also very challenging because you need to make pauses between words and also properly express the tone and put the stresses. So let's listen to an assistant. My name is Joy. And what's your name? My name is Ivan. Let's move on. Another modality is computer vision. For instance, this is our bit dancer game, where you try and catch the rings, and at the top of the TV set they have the Sber top device with the wide lens camera, as I mentioned before, and AI model ensures the tracking of the face and the limbs, hands, for instance, and sends it to the game in order to use it further on in the algorithms. Another opportunity to use computer visions is gestures. You see my colleague who is showing various gestures, and our devices recognize them. So you see we can make a pause here, or make a like or dislike of a music track, or tell the device that he switches off the sound. Another application of computer vision is a capability of recognizing a face. In this case, Dima is making a photo of himself, and the device will recognize him when he approaches the device and personalize accordingly. And other technologies of machine learning are used in our virtual assistant Salute. For instance, we have Smart Up Brain component that allows you to recognize what the phrases mean, articulated by the user, and fine-tune dialogues and the answers of the assistant. Inside Sber devices, we use transformer model from Google, and that was issued several years ago. Of course, we trained it on our data, and not just trained it, but it is a continuous process because the stream of data from our clients is very active every day. We mark it and add it to the model. Another model is RuGPT-3, the model that is using OpenAPI architecture. This is a neural network that is trained from data from encyclopedias and books and social networks, and is used for our characters Joy, Afina, and Sber at a point of time when users want to talk to us.
All the technologies which we use in our assists, we present on our portal, developers.sber.ru. There are a bunch of tools. Please welcome, please join, and you can use this QR code to visit the site and check everything out. And we have a Telegram channel which you can subscribe for and learn latest news on virtual assists and on all the technologies of AI. I'm glad to introduce to you news. This is a course for novices. The course is called Smart Market for Everyone. This class will allow you to learn more about virtual assists and understand how to create quickly your applications for those virtual assists. You can see here how to work with different modalities. You can learn how to generate the scenario tree for human-machine interface and how to do it quickly using a visual SmartUp Gra toolkit. This is a small class, just 5 lessons in a sequence, and in the end of the fifth lesson, If you want to get into detail of the artificial intelligence, we will give you a list of additional materials, additional sources. You can study them separately. Please enroll for our class and start your journey in the programming skills of virtual assistant Salute. On top of that, Vitaly, my colleague, will give you a masterclass on how to use our tools, our visual toolkits, to quickly generate these features. Thank you. Hi everybody, my name is V.Rakitin. I will give you a masterclass to create virtual assist application Salute. As you may know, we have 3 assists on our platform. This is Sber, Afina and Joy. For them we create skills which we call smart apps. And there are 3 main types of those smart apps. First is chat app. Chat app is a classical skill which you always see in virtual assists. This is a sequence of dialogues with users using different visual elements like cards, buttons, carousels, lists, and so on. The next tip is Canvas app. Canvas app turns the assist from a conversation partner to an assist, a full-fledged assist for navigation and web app. It is all deployed in WebView. The interface can be of any complexity. And by the way, it has a very cool activity to realize proactivity of the assistant. Not only the user can invoke the reaction, but also the application can invoke the reaction. Next type, native app. Native app is a classical Android applications for the most advanced developers. It has access to all possible devices. It allows to build games of different complexity. Let's speak about the way smart apps work. For example, we have a Sber box. Everything begins that I take a remote control and say a phrase, for example, hello world. And using the assistant decay, it is turned to the voice stream, and this voice stream goes to our smart NLP platform, where it is transformed to text. A JSON object is created, which is used further on, then formalization and pre-processing of text. Then POS query is made for scenario. Scenario is a web server which deploys the logic to process our voice query, setting the intent and seeing the reaction of the assist. This scenario is the application logic which is generated by the developer. After that, this scenario gives the JSON reply to our platform. This JSON reply passes through the platform and transformed to TTS stream. Partially, the information is transformed to JSON, and the user gets the result. Everything works quite easily. In total, we have 4 types of reactions. The first type is synthesized speech. This is the voice of the assist, which we use to listen. Other things are visual elements, buttons, cards, whatever. Third type are prompts or suggests. These are prompt buttons on the bottom dashboard for the user to understand how to communicate with the bot. And the last type are emojis. Emojis, emotions of our conversation. So let's try it on practice. We will use Smart App Studio tool. We will create our smart app, and we will create a notes application, the easiest one and most representative cases. We enter the name, select type, and create. Afterwards, we can straightly go to parameters option, where we can indicate the webhook. This is the address where POS query will be sent for the scenario. Let's create scenario in Smart App Quote tool. Let's create a project, name it, describe, and select the template. Basically, one of the easiest templates out of the list is a Smart Brain template. After opening the application, we got into scenario. Scenario is a status machine where each state is a certain sequence of tags. Tags are of 2 types. Tags responsible for entering the state, or tags are responsible for the assist reaction. For example, we can take a look on line 5. We have start state, and the tag is responsible for entry. regx/start, and the tag responsible for reaction is the phrase of the assist. Let's begin. Начнем. Let's have the draft. We will add the nodes. We will have the opportunity to look up the information for the node. We can change the node and we can delete it. So we outline a small template, small draft. So it would be logical to see that at the entry we would like to see the information about all our nodes. Let's make it a separate state because this case can be used in other places too. And let's make a transition from start state to start all nodes using the declarative tag go ! Which allows to execute a few states one after another. Let's save it and let's test. Let's start the application and we can see that the start block was launched and the state all nodes was launched too. Just begin to adding nodes. We assume that the user would say, note down the node, go for shopping. We have a set of compulsory phrases helping us to understand that this is the action we need, and there are also optional words and the text of our node itself. This text would be created based on any text pattern which we're going to create as any text. We will write it in any text variable. This variable will be in parse_tree object. If we have the node, we will note it down and we'll note it down in the client object. The client is the object storing the whole information about our client. Everything which we do on all sessions will be stored there. We create the nodes field in a field of a list, and in the end of this list we will append any text object. If the user didn't say anything, so we will ask him to say something what he wants to add, and in the end you can see all nodes again. Let's start the application once again. Let's enter a node, buy a car, a node, and we see the result of our application. We got to this state, we added this node. However, we're not able to bring up the whole list of the nodes. Let's do it using the JavaScript. For that, let's create a JS folder to put all scripts there, add the reply.js file containing all main functions to create answer from our assist with different visual elements. Let's make the mode all nodes reply, which transfers the list of our nodes. It brings up back the JSON with our reply. And let's fill out all compulsory fields. First is type. In our case, this is a card list. The title is My Notes, My Zametki, buttons, no buttons, we will turn it off, and auto listening, and then the list of fields which we fill out on our list. These are our nodes which we want to reflect. Let's apply map method for nodes to use this function for each text, and we will return some small things like title, value, the index of our element, and action, some event which will happen when the user presses our node. We will just send the text advanced and plus index. Let's make an advanced function using which we will send our created JSONs to our assist. Basically, this function will register our replies. We will add it to the end of the response or reply object. We made this technical function. Let's move to the main parameter. Let's switch and attach filers using required declarative tag. Just switch required to JS. In state all nodes, if the list is not empty, using this script, we can invoke our answer push method with all nodes replay result. This thing can be saved and tested. Let's look at our list and see that we have the full list of our nodes. But pay attention, please, it starts with 0, which is not very convenient for the user. Let's take it into account. Let's come back to our replies and add one to all used indexes. And now we got the nodes to buy a car. It's number 1 node. Wonderful. Let's add another one. And we can see at once that we have 2 nodes in the list. Now, pressing by each of the nodes, we see the generation of the message and index of the element. We can go over to the state, see details, and implement it. As we understood, the hit pattern to this state is really easy, is advanced and some number. For the number, we use the standard pattern from the Plo library, which is called number. For that purpose, we added this library with required tag. We attached the library, saved, and now finally we got into this script. Let's bring up this message just in a text format. We retrieve it from our client nodes by applying to number -1 object, and we see that we reflect our nodes. Great. So we know how to get our needed node in this state, and let's do the same nice reflection in a form of a card. To this end, we do the following actions. First, we create selected number variable in session object. This is the object where the information is stored about the user session. All variables created within session can be stored in the session, and they will be stored there. The client objects have fixed data, independent on the session. Temp object is created only for one inquiry. And here we will invoke similarly the answer push method, which shows show no reply. And this method we are now trying to realize. Show no reply will create a card to reflect one node. All nodes and index, which we will need now. And let us deploy it. The type will be row, the high-level inquiry, and more complicated body. We use the list of items as a body. This is a list of our visual elements. It has the type card. This card with type list card. And let's fill out all the fields. In general, we will have 4 fields. Let's note them all down. They will have a general structure, type, and content. Let's create all 4 objects. And the first one is obviously the header of our node. Next thing is the text, and then we will have 2 buttons for change and for delete. The buttons have different type. It's a buttons view, whereas textual view for nodes, buttons have buttons cell view. We fill out the header. As the text of the header, we will indicate note and index, and let's make it's a little bit grayish versus the main text, just to downgrade it a little bit. The text is default, the brightest one. On the buttons, we should enter action and change. We will send messages for changes and for deleting to our clients, and we will add change the index and delete the index. We've created it. Now we can assemble it, and let's test it on our device. To this end, we copy the webhook from publications and should also install the start button. That's wonderful. Now let's move to our SmartCAD Studio. Enter webhook into external reference, and let's test. Open Smart Notes. Hi everybody, this is Notes application, the list of notes. Add, go to the store, go shopping. List of notes added. Add, buy a car. List of notes added. Your notes, go for shopping. Wonderful. So we can see not a very beautiful card, not very nice card. Let's make it more attractive visually. Let's use tags responsible for this. Let's make tabs on the left for the text of the note and of our header, and also let's make some frame for our buttons. Let's make 10 and 10 on left and right, on top and bottom from 5. Let's make it both for delete and modify buttons to make them equal. In this way, visually, they will become more attractive. And we see that the distance provides the text twice. Add field pronounce text to make the assist pronounce the text. And let's remove declarative tag A and take reaction A also should be removed, which was responsible for bringing up the assist text. We don't need it anymore. We just do it by the pronounce text function. So, wonderful. Now we can prepare the state for changing and deleting the note. For changing, what can we do for changing? We see the session object with selected number field. We deliberately place it there. So if this field is present, it means that some note is selected. We can change it or delete it. For changing, we will ask user to give the new text of the updated note. Otherwise, if we don't have this field, selected number of empty, there's nothing to change. And we will make the embedded state. In this case, we expect that the user would give the text of the note, and if none of other intents or patterns work, we will get to the embedded state. For deleting, we will explicitly delete. If we have the selected number, we can easily take and delete our note using the JavaScript. Each of the state change or delete the node, we should zero the selected number to avoid deletion of another node. We created the image for the state, and let's put up on the screen all the nodes from the list. Save it and test what we have as a result. Start new nodes. Hi everybody, this is Notes application. Your notes, go shopping. We see that the buttons are there. Give the updated text of the note. Bring out the garbage. Your note, buy a car, delete it.
So we see that visually it gets nicer. Let's add more decorations. We remember that we have three main assistants, Sber, Afina, and Joy. Each of them have their own style of communication, their character and gender. And for this, we will have a file answers YAML, and we will have answers here selected by the code we will write now. And this will be a dictionary of our reference book of our phrases, and we'll go to stated and correct the output of all the messages. Put the block script reactions answers, where we show the text of a message from assistance. The text is retrieved through answer variable, and the parameter is the code of our phrase and the information on what assistant is selected now. And then we will have session character, parameter value, variable, and it selects the assistant we're communicating to. We will do it a bit later, but now we are filling the related answers for nodes. So say an updated word for an updated version of node. So we should be in line with all the communication styles of the assistants. There is phrase I do not have anything to update or delete. They go together, we can skip it. This is okay, they're gender neutral and they are not related to the style of communication. So how can we get our assistant? Get character ID method. From the body of our request, it'll retrieve our assistant. We will go to pure request. We have raw request. We have character ID in it. If an error comes out, we will have joy. For instance, if something goes wrong or we launch test. It is important to say if we ask a question that we have to support the answer to the question from the user. Adding a note, we ask, do you want to add anything? That's why we add a statement expecting that the user will articulate the note, and this goes to the text. And another type of reaction is emotion. Emotion is visually a very beautiful part of our assistance. Let's, in the state of adding a note, let's add emotion and joy. So let assistant be happy when we add a note. So emotion in the body, emotion ID related to code in our emotion, and put it into our answer through our answer push. Now it takes a JSON with raw type, and our body we have just explained. Now we put it together and let's test. Launch Smart Notes. Hi, hello, you're in Notes, my favorite user. Add walk a dog. Added. And now we see very nice emotion of joy from our joy assistant. Thus, through very simple things, steps, in 20 minutes, we launched a smart app. We launch a course, Smart Market for Everyone, where you can get deeper into how to create your app from scratch. Come to us and make your smart apps with Salut. Thank you very much for your attention.